So the next thing that we talk about is something called the differential equation. And the word equation means there's an equal sign in there. You have two expressions that are equal to each other. And we call an equation a differential equation if the equation has derivatives. So the interesting thing about a differential equation is that the solutions aren't numbers. The solutions are going to be functions. So if you looked at example 3 over here, it says, what function has a derivative equal to sine x? And we know that if you took the derivative of negative cosine of x, you're going to get sine x coming out. But the antiderivatives gives you a whole family of functions because we always have this plus c at the end here. So sometimes they'll give you one extra piece of information. They'll give you the function value at a point. And oftentimes they give you the function value when the x value is equal to 0. So when x value is equal to 0, that's usually what we call the initial value. Like time t equal to 0 is the initial time. So we call this the initial value or the initial condition. So in my example 3 here, I found the general antiderivative, and then I use the initial condition to solve for what c is. So I plug a 0 in for x on both sides. I know that the initial condition was equal to 3. I know that cosine of 0 is equal to 1. So we're going to get -1 plus c is equal to 3. So you could isolate the c and add 1 to both sides. And then this is the actual solution to this initial value problem. Okay. So I want you guys to try number 7 over here. We're looking for some function whose derivative is equal to this, and they give us an initial condition. This initial condition will help us find c. So I think the first thing you need to do is you need to find the antiderivative of 5x to the 4th minus 2x to the 5th dx. And then the second thing you need to do is you need to solve for c. So take a few moments to try that, and then we'll go over the answer together when you're done. So I'm going to start off by finding the antiderivative. The antiderivative is going to be 5x to the 5th divided by 5 minus 2 times x to the 6th divided by 6 plus c. Right, and we can simplify this a little bit. So this is obviously the 5s cancel out and the 2 and the 6 cancel out. So we could simplify this to give you x to the 5th minus x to the 6th over 3 plus c. And this is equal to y, right? Because if we're looking for dy dx, that means that the original function we find is called y. But we want to figure out what this constant is. So they give me this initial condition. So this tells you that you're going to get this. You're going to get y to the 0 is equal to 5 times 0 to the 5th minus 0 to the 6th over 3 plus c. So I just plug in 0 into the antiderivative anywhere I saw x. Now y to the 0, they tell us this is equal to 4. So that's going to be 4 plus 0 minus 0 plus c. This tells you c is equal to 4. So the solution to this initial value problem is y is equal to x to the 5th minus x to the 6th over 3 plus 4. And that's going to be our function that we're looking for. So we have this differential equation. It's called the differential equation because it has a derivative in there. The solution is going to be a function, which we calculated, which we found. And we were able to find this function because they gave us this initial condition that allowed us to solve for what C is. Is there any questions about number 7, friends?